complete that. And if you get a negative 30-degree angle, what you can envision, you guys, is this. Imagine the ellipse here, and you just are deciding, well, which side of the ellipse am I using? So guys, just in terms of basic logic, do you understand what we're talking about? Light coming from the side, light coming from in front, light coming from behind, light coming from one side. You know, do you see how that is dependent upon your angles of view? So for instance, okay, this may mess you guys up, I hope it doesn't. This first one, where we're seeing the light straight from the side. Well, if I move so that I'm next to the light, well, now I've got a 0 degree, now I've got this case. You see what I mean? So the key thing you need to keep in mind when you're looking at a sphere is what angle is the light coming in at, and then what angle am I seeing it at, and what is the difference between the two? That's going to determine the terminator degree angle. Okay, we'll talk more about this in a minute, but that's just the basic logic. Now, Kimmy, did you have a question?
Yeah, it's kind of a silly one, but so for the 30-degree ones, I know how you found the half of that, but where the points on the top and the bottom, does that line up with the center?
If the light source were a long way away, yeah.
Okay.
Yeah. Well, and we'll talk more. It's not too critical yet. But so anyway, I want you guys to be, what I want you guys to avoid when you're sketching is I want you to avoid this. Because that's, and that's wildly wrong. You know, and do you understand it now? If the light's hitting the front of the cube, how can the shadow be going sideways? That just makes no sense. All right, so avoid that obvious mistake. All right. All right, now, so this one will be a quick one. With the drip line, what I want you to imagine is I want you to imagine that there's something dripping onto your sphere, hitting it, rolling across the surface, and then magically, when it hits the equator, it drops straight down. And if you did that, you would get a drip line. Now, the important part of that concept is just that you're essentially mapping the geometry of the sphere into a flat plane, and that's going to come in very, very, very handy as we're working on it. Okay? Now I'm going to show you this on the same piece of paper, just because I think you'll understand it. Imagine I did this. And then so can you imagine mapping that drift line into space using a cube. Now, here's the part that I want you to think about. When we have a cube over here, or a square, we can bisect it like that with diagonals. Now I want to emphasize something. This thing that I'm about to show you, there's an important point here relative to the homework assignment. And I'll show you in more detail probably next class. But I want you, for this mechanical, to make your life simpler, I want you to locate the middle of your sphere, or the touch point. I want you to put it on your line of vision, directly above the station point. Okay? So if you're doing some fancy drawing, say like here's your, you decide that here is your sphere mechanical and all this, and this is your station point. I want you to put your sphere here. Okay, right smack on the line of vision. Now, realistically, you won't always do this, but for today's homework assignment, just do that. Do what you need to do to put the station point directly underneath your sphere. The reason I'm asking you to do this is it's going to simplify your life in terms of calculating the angle of the light. All right? And here's why. Everyone look up for a second. Do you see that if I did this, imagine this is a top view. And we're looking straight down on our sphere. And our viewer's over here, looking at the thing. And his line of vision goes straight through it like this. Everyone eyes up. Do you see that if the light is coming in on this line, do you see that it's a 0-degree ellipse? Do you see if it's coming in on this line, it's a 90-degree ellipse? If it's coming in on this line, 45. You see what I mean? So what'll happen, hey Clint, so what'll happen is, if you go to draw your sphere mechanical, and you put the light source over here somewhere, and you're calculating it out and all that, and you find the light source is coming in like this, say this is going to the radiation point, what degree is that? 30, yeah.
But it only works if it's on the line of vision?
This works exactly correct on the line of vision. If you move off the line of vision, there's an additional step that I don't want you guys to have to deal with tonight. I'll show you how to do it, so if you want to do something more complicated for your Cube City, you can do it and you know how it's done. But there's an additional step. So I just want to avoid that problem, and it's an easy way to avoid it is just to have you put your sphere right on the line of vision. Okay. Now, you guys, here's why this is important. Eyes up for just a second. So, here's my drawing of my sphere. Okay, take a look, you guys. Eyes up. Here's my drawing of my sphere, and we've just decided that my angle of view for the light is 30 degrees. So I just take this and make it into a 30-degree ellipse. You see what I mean? So that's what that's for, is if you know the angle that you're coming in at. And now here's the thing, when I do this casually, that's about 45 degrees. How do I know that? I know that because I've drawn a lot of squares in perspective. You know what I mean? I can kind of visualize it as, yeah, that's about halfway. That's close to 45 degrees. It's close enough, no one's gonna question me on it. You see what I mean? Now, if I had said, oh, that's 10 degrees, well, now I'm screwed up, you know? But this is going to get you close enough to the right answer that you'll be fine. Everybody okay with that? All right. Now, again, like I said, some of these are gonna be pretty easy to understand.